In the next few examples, we're going to be dealing with problems from the binomial distribution. We're going to be looking for the probability of exactly 7 or exactly 6 or not 6, etc. So, for this example, a test consists of 10 true-false questions. If a student guesses on each question, what is the probability that the student will answer exactly 7 questions correctly? We are going to use our calculator. I showed you how to use the formula in previous slides, but we're going to use our calculator for these problems. What I want you to do first is identify your n, your p, and your x. So n is the total number of things you have to choose from, or how many trials, or what is in your sample. There's 10 true-false questions. What is the probability that you answer a question correctly? If it's true-false, the answer of answering correctly is 1/2 or 0.5. Now, what are we looking for as far as the probability is concerned? What value does it ask for? It asks for the probability of exactly 7. So our x is 7. Now, how I'm going to write this, when I write it on the screen, I'm going to write the probability of exactly 7 is equal to, and I'm going to tell you what I'm doing on the calculator. I'm going to use the binomial PDF function, and I'm going to enter my number of trials, I'm going to enter my probability value, and I'm going to enter my x value. That's going to give me a solution of 0.117. I'll show you how to do that on the calculator in just a moment, but just remember, when I'm writing this down, the first value in my list is the number of trials. The second value in my list is the probability value, and the third value in my list is the x value. So n, p, and then x. So our answer is going to be 0.117. Let's go to the calculator, and we're going to press second and then the vars, or variables function. Now you're going to have to page down to get to the binom PDF. On my calculator, I think it's A. So once I know which one it's listed as A, I can page down to it and then hit enter to select it, or let's go in there again. I know it's A, so I'll turn on my alpha and then I will press A and it brings it up. I need to clear this because it did a binom PDF in a binom PDF. So let me quit and clear just for good measure. Second, vars for distributions. Second, A. Oh, sorry, alpha A. Second, quit. Second, vars. Alpha A. And now I want to enter my number of trials. On the new operating system, it will look like this, where it asks you the number of trials, the probability value, the x value. On the old operating system, you have to know to list it in the order that I write it on the slides. It'll look just like how I write it on the slides. So we're going to enter 10, 0.5, and the x value was 7 because we're looking for the probability of answering exactly 7 questions correctly. We go to paste, press enter, and press enter again. We round to 3 decimal places, unless otherwise told in directions. We'll round to 3 decimal places, so that's 0.117 for that question. In the next example, we have a brand name of a certain chain of coffee shops has a 46% recognition rate. An executive from the company wants to verify the recognition rate as the company is interested in opening a coffee shop in the town. He selects a random sample of 11 residents. Find the probability that the number that recognized the brand name is not 6. Okay. So, keyword here, not 6. And how do we recognize this as binomial? We've done a lot of probability questions in the past. So how do we know this is binomial? This one we can tell is binomial because either they recognize the company name or they do not. There's one of two. The events are independent, so this is a binomial distribution, or can be computed using the binomial distribution. So let's identify our n. It's always what I want you to do first. Find your NP and your x. So n would be the total number in our sample, or our number of trials, 11. The probability that they recognize the brand name is 0.46. What x are we looking for? We're looking for, well, not 6. Okay? So the probability of not 6 is equal to 1 minus the probability of 6. Remember back in the last chapter where I said you do need to know that not probability formula because we'll be using it in more complicated questions later? Well, this is one of those more complicated questions. Now, all we have to do is use our calculator to figure out what is the probability of 6 and then subtract that from 1. So we're going to do 1 minus binomial PDF, number of trials, probability that they recognize it, and what's the probability that 6 recognize it. And you can actually enter that into your calculator, 1 minus, and then go to your binom PDF, enter the information, hit enter, and then enter again, and it'll give you the information. And your answer is going to be 0.799.